everyone. Remember the last video where I left you with these 3 DIY questions? Well, thank you for mailing me your response as well as asking the queries. We'll be continuing our journey with integration by substitution today, and we'll be beginning by discussing these 3 questions briefly. The first one, nothing strikes you. Even if you try to multiply divide with 2, your 2 sin A sin B would leave you with an expression which will be in the denominator. So you cannot go further. The idea is to create this x minus A and x minus B in the numerator. So if I write this as x minus A minus x minus B, the extra thing that you've created is B minus A. So I need to divide with the same. And in my denominator we have sine of x minus A into sine of x minus B. Now you know this expression doesn't work if it does not have any sine or cos attached to it. If I try, let's say, replacing with cos over here, treating this as first term and this as second, we'll be left with cos A cos B plus sin A sin B. Whole upon, this is again sin A into sin B. If I divide, if I try to separate these terms out, we would end up getting cot A cot B plus 1, which once again does not lead you anywhere. So what do? Instead of cos, I take sine of both expressions and it works so well. You can, once you expand this is your 1 upon sine B minus A. Once you expand the numerator, this gives us sine x minus A into cos x minus B minus sine x minus B into cos x minus A upon sine x minus A into sine x minus B. Now separating out the terms, we get from the first expression sine x minus A gets cancelled and you're left with cot of x minus B, and from the second expression we'll be left with cot of x minus A. If you remember the formula for integral cot x, then very well, else you can refer to previous part of integration by substitution. I'll link it for you in the description box and also under the I button. And here you can give your final answer. Second one looked like a complete maze. If you try to put your denominator as t, well, the answer is not in the numerator. So what do? Again, an extra twist in the question. What you can do is, you can try creating this term in the numerator. So for that, I am adding x, and of course I have to subtract it too, and writing the remaining term as it is upon x into x plus sin x. If I try to separate out the terms, for the first term I am left with only 1 by x, and for the second one, if I take minus sign common, you would see your x getting cancelled from here and will be left with 1 plus cos x upon x plus sin x. Do you think adding and subtracting x and separating out the terms have helped us? Of course it has. Look at the first one. It simply became integral of 1 by x, for which we all know the answer is log mod x plus c. Likewise, look at the second one. Here, if you try to take your denominator as t, the derivative 1 plus cos x is right there. So I am only discussing. So if I try taking this integral as simply I1 and put this as t, you know the derivative for x is 1, derivative for sin x is cos x, whole dx becomes dt. And the integral I1 also changes to dt upon t. You can integrate this one as well as this one. But hey, do not forget to combine your constant of integration in the end and write your final answer as log mod x. This would give you the final answer as log mod of x plus sin x plus C1 from here and C2 for here get combined, and you write the constant of integration only once. Look at the third one. We did a similar question in the previous video. Now in order to create this on the top, I can simply write my minus alpha as plus alpha minus 2 alpha. Just watch this out. So your integral changes to sine of x plus alpha minus 2 alpha whole upon sine of x plus alpha into dx. Now, if I try to treat this as one term and this as the other one, sine of a minus b gives us sine a into cos b minus cos a into sine b whole upon sine of x plus alpha. And now, just like your previous video, please separate these terms out, make use of your integrals for trigonometric functions and get cracking on the question. Moving on with the volley of questions, have a look at the fourth question. Super simple? Yes. If you put your denominator as t, that means I say let e to the power x plus e to the power minus x is t. Derivative for e to the power x is ex, and this one would be e to the power x into minus 1. Whole of dx is dt, which gives us the integral as dt by t, and once again the answer is log mod t plus c, which gives us log mod of e to the power x plus e to the power minus x plus c. Let's try to go slow. You all know the derivative for log x is 1 upon x. What if I add one extra log to it, or maybe one more? What happens? You know, if I focus on 1 by x, then I'll have to take log x as t. However, what do I do with this? So, in such questions, try to take the biggest term containing log as t. And now, see what happens. If I put my log of log x equal to t, then derivative of log as the first function would be 1 upon log x into derivative of log x is 1 upon x. Dx is dt. I'm making use of the chain rule here. You want to know what's chain rule? Well, find the video in the link from the differentiation playlist. I'll also link the same for you at the end of this video. So, going back, now as you can see, this integral can be written as 1 upon x into log x into 1 upon log of log x into dx. So, if this is taken as a function, well, the derivative is right there. So, my integral now changes to 1 upon t, and 1 upon x into log x is replaced with dt. So, the final answer is log mod t plus c, and in the end, don't forget to substitute your t as log of mod log x plus c. Have a look at the sixth question. Getting some memories back from your trigonometry? Well, if you have done your trigonometry well, then this question is too simple. You know, you look at the highest number and try to break it in the given two numbers. So, for this question, you can write 5x as 2x plus 3x. Now take tan on both sides. So tan 5x becomes tan of 2x plus 3x. Let's apply the formula for tan a plus b. That gives us tan A plus tan B whole upon 1 minus tan A into tan B. Let's cross multiply. We get tan 5x minus tan 2x into tan 3x into tan 5x can be written as tan 2x plus tan 3x. And let's focus on our integrand. This expression could be expressed as, so your tan 2x, tan 5x minus tan 2x minus tan 3x. Now we are going to replace your integral with the new term as integrating tan 5x minus tan 2x minus tan 3x. Now in our previous video we had derived the formula for integral tan x as log mod secant x. So we are going to use the same over here. The answer becomes log mod secant of 5x, and you know this is not a standard function. So instead of multiplying with 5, which we did in differentiation, we rather divide with 5, since integration is the reverse of differentiation. So divided by 5 minus log mod secant 2x whole upon 2 minus log mod secant 3x whole upon 3 plus c. Time for some DIY. Note down these questions. So this brings us to the end of integration by substitution. Don't forget to share your solutions on this email ID and share your feedback in the comment section below. Make sure to share and like this video, and don't forget to subscribe. I will see you with a new video. Until then, bye-bye.